Hey everyone. So in today's world of manufacturing, it's all about moving faster and being more precise. But what happens when the old ways of cutting metal just can't hack it anymore? Today, we're going to look inside a technology that is absolutely changing the entire game.
So let's just set the scene a little bit. If you're in the fabrication business, this probably sounds all too familiar. You're in a constant race against the clock, right? You're trying to hit tighter deadlines, handle more and more complex demands from customers. It's a daily battle.
And these are the usual suspects, the headaches that come with older methods. You've got slow production that just creates these massive bottlenecks. You've got expensive material literally being thrown in the scrap bin because the cuts are just a tiny bit off. There's that relentless pressure for higher and higher precision. And of course, all of this, it just hammers your bottom line. Here's the deal. This isn't just about making things a little bit better. It's about survival. In today's market, which is just hyper-competitive, efficiency and accuracy aren't just nice-to-haves. They are the absolute price of admission to stay in the game.
But what if there was a solution? Something that didn't just put a Band-Aid on these problems, but made them totally obsolete. A real leap forward. Okay, here we go. This is the technology we're talking about today, the high-accuracy fiber laser cutter. And I want to be clear, this isn't just some minor upgrade. It's a total powerhouse designed to completely revolutionize metal fabrication from the ground up. So how does it pull it off? What's the secret sauce that makes this machine so different? Let's peel back the layers and break down the key parts that give it these incredible powers. First and foremost is its defining feature, high accuracy. So what does that actually mean in the real world? It means it uses incredibly advanced optics and a rock-solid stable frame to make sure every single cut is exactly where it needs to be. This gets rid of all those tiny errors, which in turn just slashes material waste and pretty much eliminates the need for costly redos. And then there's the raw power. I mean, this machine can be armed with up to a staggering 20 kilowatts of cutting force. But brute force is only half the story. Now, this is where things get really, really smart. It's all about versatility. You don't always need a giant hammer. You can dial the power way down to 1.5 kilowatts for super delicate, thin stainless steel. Or you can crank it all the way up for thick slabs of carbon steel, aluminum, or even tricky stuff like brass and copper. It's about having the perfect tool for any job you can throw at it. And all that power needs a place to work, right? The machine has a huge 1,500 by 3,000 millimeter working area. And that size is so important because it lets you work with massive sheets of metal, run bigger batches, and plan out your cuts to use every single square inch of material. It's just incredibly efficient. Of course, all this amazing hardware would be nothing without a sophisticated mind controlling it. The source material called it the brains behind the brilliance. And honestly, that's the perfect way to introduce the software. So let me introduce you to the Cypcut Control System. This is what makes the machine smart. It's designed to be super user-friendly, yeah, but its real power is in its intelligent features. Things like nesting, where it automatically arranges all the parts on a sheet to create the absolute minimum waste. It figures out the most efficient way to cut everything, saving time and empowering pretty much any operator, no matter their skill level, to produce perfect, complex parts. And finally, we have the Boci Laser Head. Think of this as the tip of the spear. This is the component that's responsible for focusing all that laser power into a stable, super high-quality beam. And that consistency is absolutely essential for getting that pinpoint accuracy we talked about, not just once, but over and over again. Okay, so we've geeked out on all of the impressive specs. But what does all of this technology actually mean for a business? Let's connect the dots from the features on the factory floor to the real impact on the bottom line. And this just says it all, doesn't it? On the left, you have the old way, slow, manual, tons of waste, inconsistent quality. And on the right, the new reality with a fiber laser. Fast, automated, optimized material use, and unwavering precision. The contrast is just night and day, and it all leads to much lower operating costs. So what you're really looking at here is a clear path to being way more competitive. You increase your productivity, you cut your waste, you lower your costs, and you deliver a much higher quality product. And when you put all of that together, you're not just competing anymore. You're in a position to actually lead the market. All right, so let's zoom out for a minute and really think about the big picture. What's the major takeaway from this whole technological shift? The main point is this. This is so much more than just a new piece of equipment. It represents a fundamental change.
It sets a completely new benchmark for what's possible in terms of speed, precision, and efficiency. This is the new standard for how we shape the metal that builds our world. And that kind of leaves us with a really fascinating question to think about. As our tools get this good, as they achieve this level of near-perfect precision and automation, what does that mean for the role of the human operator, for the skilled artisan? It's a question that could redefine the entire future of craftsmanship itself. Thanks for watching.